Hello, everyone. My name is Julian Tissier. I am working at Snowflake as a machine learning scientist. And today I will talk to you about how to prepare your data for an efficient RAG chatbot. So first, in this presentation, I will present what is a RAG chatbot, and I will also present you the RAG chatbot that we developed here at Snowflake. I will then explain what kind of documents we are using in this RAG chatbot. And then I will start with different steps that we did to ensure that the chatbot was as efficient as possible. So in the order, we are going to see how we process hyperlinks, how we process tables, how we process images, and finally, how to process PDF. So first, let me talk to you about the Snowflake RAG chatbot that we developed. So at Snowflake, we have developed a RAG chatbot to help all Snowflake employees. So it happens very often that Snowflake employees need help, for example, because they don't know how to set up the printer, they don't know how to set up their monitor, their laptop, and we have an internal website at Snowflake that contains all the information, but sometimes it's not very easy to use because you need to search for the correct information and you need to know how to use properly this search engine. So what we developed is a more friendly way to find this type of information. We cover different topics, for example, IT, HR, but also all questions related to travel and expenses, and also questions related to workplaces. And we have a nice chart interface that can show you response in real time. Let me show you an example, a real life demo. Okay, so this is our chatbot that we developed at Snowflake, and we can ask different questions. For example, how can I print on macOS? So our chatbot will retrieve information from this internal knowledge base, and then it will generate a response to answer that question. So now the response is generated. And as you can see, the response contains both text, but it also contains images. For example, this question was about how can I print on macOS, and the response is a tutorial that explains how we can print on macOS. So the tutorial contains screenshots from the Mac laptop. So in our response, we are able to have both text and images. And we also display the sources used to generate the response. So in this example, there's no links, for example, to click on another website, but it can happen that sometimes the response also contains clickable links to help the user to navigate quickly to what they want. So now let me talk to you about what kind of data we are using in this chatbot. So on the left, you have an example of what one can find in our internal website that contain information about different questions. For example, this article is about how to set up a printer when you want to print something on a Windows laptop. So our internal knowledge base is a website, and all the articles are web pages. So for articles related to IT, we have a lot of images. It can be PNG, it can be JPG. And for HR articles, we have a lot of tables. For example, we have different locations, different Snowflake locations, and the information can be different for each location. So that's why we have information containing tables. And it can happen sometimes for some articles, we have PDF as attachments. So as I said, we have both HTML web pages, images, and also PDF. All this data can be considered as unstructured data. So yes, the web pages are saved at HTML, and we have a process, a daily process that ingests all the articles from our internal websites and process all the unstructured data, and then they are stored in Snowhost tables or Snowhost stages. So a Snowhost table is a SQL table with a structured information, for example, the title of the article, the content of the article, the creation date of the article. And for stages, it's places where you can store and save files, for example, images or PDF. So yes, that's the type of data we are processing. It's mainly unstructured data. But we cannot use directly HTML for our RAG, and I'll explain you why. Because here's an example of the HTML that one can find in an article. So HTML is not only content, it's also style. And it contains information about, for example, the font size, the color size, and that kind of information. So displayed on the screen, you can see that for some paragraph, we have the font type, the font size, and if you give this information directly to your RAG chatbot, it's not going to be very efficient because it contains a lot of non-useful information. So that's why we cannot directly send raw HTML to our chatbot, and we need some steps, some additional steps to make it more efficient. Now let me talk to you about the different steps that we did to make our RAG chatbot more efficient. And I will start to talk about how we process hyperlinks. So usually in an HTML page, a hyperlink is created by using what we call an A tag, because the information is contained inside this tag. And if we give this directly to the chatbot, as I said, it's not going to be efficient. So what we did in the first step was to only extract the text with a Python package called Beautiful Soup. Beautiful Soup allows you to extract the text based on an HTML web page. But if we do that with Beautiful Soup, in our case, the link that says click here and links you to the homepage of Google, if you only extract the text, you are going to get only click here. So you are losing the information about the link. And that's bad for your chatbot because that means it would not be able to have any links, any usable links in the response. So what we did, instead of Beautiful Soup directly on the HTML, we have an additional step, and we replace the click here with a markdown link. So in that case, we extract the URL of the link and we directly put it into the content of the link. That's the second step that you see on the screen. And then we repeat the same process, the text extraction with Beautiful Soup. And in the end, what we extract is the markdown link. And why are we using markdown links? First is because our app that I just showed you is developed using Streamlit, and Streamlit is able to display a clickable link if you give it markdown links. And another benefit is that LLMs are very good at understanding and generating markdown links. So if the content of the article used by the LLM contains markdown link, then the response generated by the LLM will also contain markdown links. And that's what you want in the response displayed to your user. You want to keep the link, so it's better to have markdown links in the content that you send to the LLM. Now I will talk to you about how we are processing tables from HTML web pages. So it can happen that in some articles, we have tables, as I said before, with information for different locations. So on the screen, you can see an example. We have different locations for London and for Amsterdam. And for each of the location, we have information about the number of people that you can fit in a room. In HTML, everything is inside the tag. So this table is created with a table tag, and then each row is written with what we call a TR tag. And each cell of the row is written with what we call a TD tag. And it can happen that we have multiple columns and multiple rows. We don't know in advance how many rows and how many columns there is in a table. So if we do it the naive way, that means directly extract the text from the HTML page using Beautiful Soup, that's what we obtain. So at the top of the slide, this is the HTML tag that comes directly from our documents. You can see that the first word is table. That means it's a table. And if we use Beautiful Soup, we obtain what is displayed at the bottom of the screen. So in that case, it will be training room, name, capacity, classroom, capacity. And as you can see, the information is not properly extracted because Beautiful Soup doesn't know that this is a table. So it has columns and different cells. Beautiful Soup only extract the text. You are losing all the information, all the structured information that your table contains. So that's why you cannot directly use Beautiful Soup to parse any HTML web page. If you give this extracted text to your LLM, the response generated with this content is going to be bad. So in order to fix this issue, we have an additional step. So starting from the left, which is the HTML web page, as I said, it contains different tags, for example, TR and TDs. We are using the Python library called pandas, and pandas is able to read this table HTML code. Pandas is going to convert this HTML code into a data frame object. For those who are not familiar with the pandas notations, a data frame object is some kind of table object that contains different columns and different rows. So that's exactly what we have in a table. And this Panda library is able to export this data frame object as a JSON object. A JSON object is a text object that contains both columns names and also the value associated for each of the column. So in our case, it's good to have JSON objects because LLMs are very good at understanding JSON objects. I mean, they are way better to understand JSON objects than to understand HTML tables. So if we look at what happens when we process the HTML table, so at the top of the screen, we have HTML code that I just shown you before. And at the bottom of the screen is what we obtain after our processing step. And as you can see, for example, we have office location, London, training room name, Norfolk. So with JSON, it's much easier to understand that for this location, London, the training room name is Norfolk. And if we go back to what we had, if we did the naive text extraction, it's not possible to extract the name of the training room for London. So if you want your chatbot to be very efficient, you need to give to your LLM very easy to understand data. And another advantage is that this JSON object is much simpler to understand for the LLM. And also you can make it very trustworthy for a company that has a lot of tables and a lot of information contained in this table. The information extracted is much reliable than having only the naive text extraction. Now I will talk about how we can process images. So in many IT articles, we have tutorials with a lot of screenshots. For example, how to set up a printer on Windows. So if we use directly the HTML code and send it to the LLM, well, first, it's not directly the image that we are feeding to the LLM, it's text. So the LLM is going to ignore this image tag. And also, if we want to extract any text or any information with Beautiful Soup, we are going to lose any information because Beautiful Soup only processes text and not images. So what we did was to use a VLM. So a VLM is a visual language model, and it is very similar to an LLM. In an LLM, you give as input a text, and you receive as output also a text. For VLM, you give as input a prompt, for example, describe this image, and you also give as input an image. And the VLM is going to give you as output a text which corresponds to the instruction that you gave in your prompt. So let me do a quick live demo. Okay, so this is a live demo that you can try on Hugging Face. The first thing is to select the image that you want to send to the VLM. In my case, I select this image of a cake, and I just type my prompt. And we can see that the LLM is able to recognize that this image is an image of a birthday cake and that it contains also candles. So if you have a knowledge base with a lot of images and all the images have information, the VLM is able to generate a description for each of the image. And this image description can be used in your RAG. You cannot use directly the image, but you can use the image description for the retrieval of your RAG. So in our case, we have a lot of images stored in a snowhouse stage, as I said at the beginning. And I also deployed a VLM on SPCS. So SPCS stands for Snowpark Container Service, and it's a Snowflake tool that you can use to deploy any kind of application. In my case, it was a VLM. So I created a prompt, as you can see on the left part of the slide. The prompt is describe this image and extract as much text as possible from the image. And then for each of the image stored in a snowhouse stage, I pass both the prompts and the image directly to the VLM. And we can see on the right that it generates a description for each of the image. And then I save all the description corresponding to each of the image in a snowhouse table. So I obtain a mapping between each ID of an image and its corresponding image description. And I created this as a pipeline, and this pipeline is run daily to ingest all the new uploaded data on the Snowhost stage. So in the end, I obtain a Snowhost table that contains both the ID of the images and the image description. And now let me explain you how we can use it to have images in our chatbot. So the first step is to get the image tag from the HTML web page. This is what's displayed at the top of the screen. And you can see there is a part of this text displayed in purple. So this part is the ID of the image. And I'm using this ID to retrieve the corresponding image description for this image. And in my HTML process text, I replace the image tag with a custom pattern. I call it a custom pattern because it's not a markdown link. It's not anything that exists. I created this pattern. So this pattern is composed of two parts. The first one is the ID of the image written in between the triple backticks. And the second part is the image description written in the triple square brackets. And then this custom pattern is used in two ways. First, for the retrieval, to be able to retrieve this image if the user query is very similar to this image. So in that case, we only keep the image description and not the ID. And then we are also using this for the generation. And in that case, we are not using the image description. We are only using the link to the image. And that's what is given to the LLM. So the LLM is able to display the markdown image in the response, and Streamlit is able to render the markdown image as a real image if it has access to the URL of the image. So that's how we can have images in the response. And finally, let me talk to you about how we process PDF in our RAG chatbots. So all the PDF are stored in a Snowhost stage. And I set up a pipeline that also runs daily that converts, or I should say, that extracts the text from all the PDF using the Python package called PyPDF. And this extracted text is saved in a Snowhost table. And then our RAG is able to directly search for information into this Snowhost table. So in the end, our search space for the RAG contains both articles, processed HTML web pages, and also processed PDF. So that's why we can retrieve information from both web pages and PDF at the same time. Okay, let me recap what I just explained to you. So the main point of my presentation is that if you have a lot of HTML documents that you want to ingest by your RAG, it's not a good idea to use only the HTML code. You need to process it to make it easier to understand for your RAG chatbots. So what works best is very simple and plain text without any HTML tags, for example. So LLMs are very good at understanding markdown links, markdown images, and also JSON strings. So that's why I was using all this type of formatting to give the information to my LLM. About the development time that I needed to create all the different steps, it took me, I should say, it took us a few months, 2 to 3 months. So yeah, if you want to create it from scratch, I think it will be much faster for you because you don't have to research what is the best format to use. And about the processing time, so in our case, we have about 1,000 documents and about hundreds of PDF, and the total processing time is between 20 and 30 minutes. The main bottleneck is the image description, mainly because we're only using one GPU. I think this could be made made faster with more GPUs. So yeah, for 1,000 documents and a few hundred of PDF, that's quite short. So I hope that you will be able to reproduce all the steps that I explained to you and make your RAG chatbot as efficient as possible. Thank you and enjoy your day.